Alright, so the problem today is that there's a farmer, and he has 750 feet of fencing. With that 750 feet of fencing, he wants to build a pen in the shape of a rectangle, and inside of that pen there will be 4 equal but smaller rectangles. So we need to use all 750 feet of fencing, but we need to maximize the area of the entire rectangle and each pen. So what we need to do is first draw a diagram of how we think this is going to look. So if we have our original rectangle, we know that we have to have 4 separate pens inside. That can be vertical or horizontal. We'll do it horizontal just to start. So on one side we have Y, and Y, and we have X, 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 X. And we know each of those X coordinates are equal because each pen has to be equal in size. So we know that our area is always going to be A equals X, Y, because those are each of our sides. And now we need to find how much fencing we're actually using. So we know we're using 750 feet of fencing, but we need to find an equation for that. So what we know is that we need to add up our 2 Y coordinates. So we have 2 Y, but we actually are using 5 X coordinates because we're using the 2 on the outside and then 3 lengths of fence on the inside. So 750 equals 2Y plus 5X. Now what we're going to do is we're going to solve for Y. So we say that 2Y equals 750 minus 5X. Now we know that Y equals 375. Excuse me. We know that Y equals 375 minus 2.5x. So what we can do with that equation is plug in our Y into our area equation because we have 2 variables. So we can plug in Y in terms of X into area, so A equals X times 375 minus 2.5x. We know that because we just solved for Y, and by foiling that out we get A equals 375x minus 2.5x squared. What we need to do from here, because it's an optimization problem, is we need to take the derivative of our area equation. In order to do that, A prime equals 375 minus 5x, and after we take the derivative we need to find where this equals 0, so set that equal to 0. 5x equals 375. Now that we know x equals 75. Well, in this case, let's just check that 75 is a maximum. So A prime, we make our number line. We say 75. If we plug it back into the equation, less than 75 we get a positive, greater than 75 we get a negative. Going from positive to negative, we know that we have a maximum at that point, which is what we want because we're trying to maximize the area. So if we plug that into our equation for Y, so we say that Y equals 375 minus 2.5 times 75. After we plug in 75 into our Y equation, we know that Y equals 187.5. And if we multiply that out into our area equation, A equals X times Y, we know that our area equals 14,062.5 meters squared.
Feet squared.
Pardon? the unit is feet squared. And that is how you maximize the area. Thank you.